when it comes to finding derivatives, one of the most important rules, and something that a lot of people miss, is what's called the chain rule. And so the chain rule comes into effect whenever you have function composition going on. So what this says is if we have some function, capital F, and it's f of g of x. So what that means is there is a function plugged into another function. The way that you do that derivative is you do the derivative of the outside function, but you keep the inside the same, and then you do what's called chaining on the derivative of the inside function. Okay, so derivative of the outside, leave the inside the same, and then we're going to multiply by the derivative of the inside function. It is possible that you have multiple compositions going on, in which case you would just keep doing the derivative of the next outside function and then keep chaining on the derivative of the inside each time. Okay, so here we'll look at some examples. Again, the main part, what you want to be able to figure out is what are the two functions that are composed. What is the outside function, what is the inside function, and then you need to be able to identify that so that you can then take the derivative. So the first thing I'm going to do here is I'm going to rewrite this as x squared plus 1 to the 1/2 power. Anytime you have a radical, you want to rewrite that as a power, as an exponent, so that you can use your power rule. And now what I see here is I actually have a function, x squared plus 1, inside of another function, which is x to the 1/2, or the square root of x. So to find my derivative of this, I'm going to do my outside derivative first. Well, my outside function is my 1/2 power, or my square root. So I'm going to do that rule. That rule says, power rule, I bring the 1/2 down, and then I subtract 1 from the exponent. Right? Well, the inside function, the x squared plus 1, that's just going to be along for the ride at first. Okay, so I'm going to go ahead and do the derivative of the outside part, leave the inside the same, and then I'm going to chain on the derivative of the inside function. So the derivative of x squared plus 1 is 2x. And that is our derivative of that function. Sometimes it might be advantageous to simplify this. Like you could do the 1/2 times the 2 and get rid of those. So you could just say x times x squared plus 1 to the negative 1/2 or whatever. But I'm just going to leave it as is. Unless we need to simplify for some reason, we'll leave it like that. Okay. Number 2, I've got a couple different functions here that I want to do the derivative of. And it's to show you a subtle difference here. So for part A, we have y equals the sine of x squared. So again, I have a function, x squared, inside of another function, which is sine x. So I'm going to do the derivative of the outside function. The derivative of sine is, let me write y prime first. So y prime is going to equal the derivative of the outside function, which would be cosine. Keep the inside function the same, x squared, cosine of x squared. And then we're going to chain on the derivative of the inside function, which again is 2x. And there's our answer for part A. For part B, a subtle thing here is to know what that means for it to say sine squared of x. Sine squared of x means the sine of x squared. So if you can think about it in that form, you should be able to see that we have function composition. We've got sine x plugged into x squared. So the derivative of this is going to be to first do the power rule, which would be multiply the 2 down, subtract 1 from the exponent, so I get 2 times sine x to the first power, and then I'm going to multiply by the derivative of the inside function, which is the cosine of x. Okay, so a subtle difference there in how that was presented can give you completely different answers. Number 3, y equals x to the third minus 1 to the 100th power. Again, here we just have a simple power rule. So we're going to do 100 times x cubed minus 1 to the 99th power, and then we're going to chain on the derivative of the inside, which would be 3x squared. Number 4, we have a radical on the bottom of a fraction. So the first thing I want to do before I do the derivative, I want to rewrite this. So we're going to take the x squared plus x plus 1, and I want to write that with just a single exponent here to represent this. So cube root means 1/3 power, but that cube root is on the bottom, which means we're going to make that a negative 1/3 power. So we're going to rewrite this as x squared plus x plus 1 to the negative 1/3 power. So then when we go to find the derivative, we can start with our power rule. Derivative of the outside function would be negative 1/3. Subtract 1 from the exponent, so negative 1/3 minus 1 is negative 4/3. Keep the inside function the same. And then multiply by the derivative of the derivative of the inside function, which is 2x plus 1. Notice how I put that in parentheses here, because I have more than one term. Everything I've done so far, my chain has just been a single term, so I don't need to use parentheses around that. But if your chain is more than one term, make sure that you put that in parentheses so you can see that. We do need to make sure that we multiply by that whole thing. Okay. Number 5, 2x plus 1 to the 5th times 3x to the 3rd minus x plus 1 to the 4th. So a couple different things going on. First, we have a product, right? It's multiplication here. So I've got 2x plus 1 to the 5th power, that's my first thing, my first function, multiplied by x to the 3rd minus x plus 1 to the 4th power. So what I actually need to start with here is the product rule. The product rule says we're going to leave the first the same, and then we're going to multiply by the derivative of the second. Well, the derivative of the second requires us to do a chain rule. Right? So the derivative of x cubed minus x plus 1 to the 4th power would be 4 times x cubed minus x plus 1 to the 3rd power, chain on 3x squared minus 1. That's the derivative of the second. So the first times the derivative of the second plus the second, x cubed minus x plus 1 to the 4th, times the derivative of the first. And again, the derivative of the first is going to require us to do a chain rule as well. We're going to have 5 times 2x plus 1 to the 4th power, chain on the derivative of the inside function, which is 2, and at that point we are done. So these things can get kind of messy whenever you have multiple rules happening at one time. We had to first recognize that the whole thing was a product, but then we also need to be able to recognize that each one of those terms requires a chain rule when you do the derivative. And so it can get, again, a little messy. You could have the quotient rule mixed in with the chain rule. There could be a lot of different things going on here. So you just need to think about what are you starting with, and then when you get to a certain part, what rules does that require as well. Okay, so I'll leave that as is. I'm not going to try to simplify that. Number 6, y equals e to the sine x. So y prime is going to be, so here I have an outside function that we have e to the x, and then in for x, we plugged in sine x. So there is a function composition here where our outside function is e to the x, our inside function is sine x. So the derivative of e to the x is e to the x. So when I do the derivative of the outside function, I'm still just going to have e to the sine x. My chain is going to be the derivative of the inside function. So the derivative of sine x, which is cosine x. One more thing here to talk about at the very bottom, and that is if we have an exponential that is not e to the x. So let's say we have some number to the x. When you do the derivative of that, you get the same thing times the natural log of whatever that base is. So if you think about e to the x, if that is e to the x, we get e to the x times the natural log of e, and the natural log of e is 1, which is why we just end up with e to the x. But any other base with an exponential, we have to chain on this natural log of a. So a quick example here, we just have y equals 2 to the x. The derivative here, y prime, is going to be 2 to the x times the natural log of 2. And that's just a rule to remember as well, in addition to some of our other basic derivative rules.